Now, the last one. This angle. What is the degree measure of this angle? 330, right? Actually, the full angle of circle is the 360 degrees. Then you subtract the 30 degrees from the 360. You get the 330 degrees, right? So now, by the coordinates of the point of intersection, you know sine of 330 degrees equal to root of 3 over 2, right? So you have the root of 3 over 2. And then cosine of the 330 degrees equal to negative 1/2. Any question? And you need to check this fig 5.27 on the page 437. Okay? Try to familiarize yourself with this fig. So now you can see if the 30 degrees, you have the cosine equal to root of 3 over 2, sine equal to 1/2. 60 degrees, cosine is equal to 1/2, and sine is equal to root of 3 over 2. And then 90 degrees, cosine 0, sine 1. Then 120, right? 1, 2, 3, 4, 4 times 30, you get the 120. So for the 120, cosine is equal to negative 1/2, and sine is equal to root of 3 over 2. And then here, 150, cosine is equal to negative root of 3 over 2, and sine is equal to 1/2. And then 180, then you have the cosine equal to negative 1, and the sine is equal to 0. So you need to familiarize yourself with the sine and the cosine of the multiple of all these common used angles. 90 degrees, 45 degrees, 30 degrees. Now let's look at the one problem. The problem 27 on the page 443. We need to find the cosine of the 13 pi over 6. So it's the page 443, problem 27. Find the value of cosine of 13 pi over 6. So first, you may try to rewrite this as the multiple of 2 pi plus another angle. So we know this guy is equal to 2 pi plus pi over 6, right? Because when you divide 13 by 6, you get the quotient equal to 2. And then remainder equal to 1, right? So you just replace 13 by 2 times 6 plus 1, then you get the 2 plus 1 over 6. Right? So you get the 2 pi plus the pi over 6. And now you go back to the graph. So 2 pi plus pi over 6. So 2 pi, 1 revolution, right? And pi over 6 here. So cosine of the pi over 6, same as the cosine of the 2 pi plus pi over 6. So that should be equal to root of 3 over 2. Right? So in this way, we find the cosine of the 13 pi over 6, which is equal to root of 3 over 2. Now let's look at another example. We have the cosine square of negative 210 degrees minus sine square of negative 210 degrees. So this symbol means, okay, the square of the sine of x. So first you take the sine and then you take the square. So now let's first get the cosine of the negative 210 degrees. What is the value of the cosine of the negative 210 degrees? Let's check the graph, right? So negative 210 degrees, we know if you rotate clockwise for half revolution, you get negative 180, right? And negative 180 plus negative 30 degrees, right here. So this guy is the negative 210 degrees. And what is the cosine of the negative 210 degrees? Which one? Negative root of 3 over 2, right? So we first get the cosine of the negative 210 degrees equal to negative root of 3 over 2 and then square. Now, how about the sine of the negative 210 degrees? 1/2, right? Positive 1/2. Okay, so we get the positive 1/2, and then you simplify. You get 3 over 4 minus 1/2, and finally you get 3 over 4 minus the 1 over 4, then finally you get 1/2. Okay. So at least you need to memorize these several basic sine and cosine values. So you have the sine 30 degrees equal to one-half, and this can be written as the root of 1 over 2. And then sine of 45 degrees, this is root of 2 over 2. And sine of 60 degrees is equal to root of 3 over 2. Then the cosine 30 degrees is equal to root of 3 over 2. And cosine 45 degrees is equal to root of 2 over 2. And cosine 60 degrees is equal to 1/2, and this can be written as the root of 1 over 2. Do you see the pattern? See, when you move from 30 degrees to 45 to 60 degrees, you get the numerator of the sine equal to root of 1, root of 2, root of 3. And when you move from the 30 degrees to 45 degrees to 60 degrees, you get the cosine, okay, the numerator of cosine equal to root of 3, root of 2, and root of 1. Okay, hopefully this can help you to memorize all these values. Now let's talk about the reference angle. Okay, reference angle. So suppose we have a non-quadrantal angle. That means this angle is not a multiple of 90 degrees, right? It's in one of the 4 quadrants. Then we need to define the reference angle of this given angle. Let me call this angle theta. Okay, we use the red for this arranged angle theta. How do we define the reference angle? If this arranged angle is between the 0 and 90 degree, then its reference angle is just equal to itself. So theta prime equal to theta in this case, if this theta is between 0 and 90 degrees. So in the first case, our arranged angle is between 0 and 90 degrees.